And today we're going to be learning about the affine cipher. We're going to be learning about the equation, so the encryption equation and decryption equation. So let's get into it. First off, we had to start off with the encryption equation, which is y equals ax plus b mod 26. Y equals ax plus b mod 26. So now you'll be wondering, what is a, what is b, what is y, what is x? So it starts off with a and b. So for regionals and invitationals codebusters, what you guys will get is they will give you the a value themselves, the a and b value. They'll give them yourself, and the a value is going to be an odd number. So it's going to be a value anywhere from 125 is going to be an odd number, and for the b value is going to be a number 125. It can be even, it can be odd, it can be anything. And so these are the values that are given during the test, and these are the values you have to find. Especially for encryption, what you have to find is this value right here, the cipher value, because they're going to be giving you plain text. So let's just go over it real quick for a sec. We have A, which is going to be the first given value. You have B, which is going to be your second given value, and then X is going to be the plain text. So once you convert it into a letter, the number you get is going to be your X, and the Y is going to be your X in number form. So let's look at right here. If you guys remember from last time, this is very, very important. You guys need to have memorized this practically. So A starts off with 0, B starts off with 1, C starts off with 2. So remember that A starts off with 0. So when you're plugging it in like this right here, so when you're plugging in values right here, let's imagine that you wanted to plug in M. So X, the letter they give you M is X. So you have to find M, which is going to be 12. And so right here you plug in 12. Then right here you saw, and with the A and B given equations, you multiply, you solve for the equation, and you get your answer. Okay, now let's move on to decryption. Decryption is the exact same format. However, you have the same variables, you just have a different equation. And so you have A inverse 1. Remember, this is a different type of inverse. So I'll explain later how to get this equation, but don't inverse it using like 1 over a to the power of 1 or 1 over a. That's the wrong type of inverse. You have y minus b mod 26 equals x. So as mentioned before, a is going to be your odd numbers only given value from 125. B is going to be your 125. They actually give you these values, so you don't need to calculate it. X is your plain text, y is your cipher text. So in states and nationals, they give you some sort of questions that often ask you how to solve for these. And right now we're not going to be focusing on them. Right now we're just going to be focused on encryption and decryption, of course. And now I'm going to teach you how to even like derive this formula in the first place. So we start off with our encryption cipher, which is going to encryption equation, which is going to be y equals ax plus b mod 26. And so now let's imagine that our A and B are 7 and 13. Okay, let's go back in here. So y equals 7x plus 13. Let's ignore the mod 26 for now because we can come back to that later. And so we have to start off with, actually, we'll plug these values in later. But once you have the y equals ax plus b, just ignore this mod 26 right here. You don't need it for now. You have to always add at the end. So what we have is subtract the b on both sides because you're trying to isolate the x, kind of like algebra. So you have y minus b equals ax, and now you have to divide the a on both sides, and that's going to equal y minus b over a equals x. Now we can't have denominators in affine cipher just because we have to try solving for whole numbers like these ones right here. So we have to refrain from using affine cipher. And another way to write y minus b over a is simply just a inverse 1 times y minus b equals x. Because a to the power of negative 1 is nothing but 1 over a. And so after you get this equation right here, remember that you can't take the inverse of a. So you can't like be like 1 over 7. You can't have 1 over 17, 1 over 23. That you can't just do that because that will give you a really weird number. You can't solve for that in the first place. And so after you get this formula right here, what you have to do is you have to take this value right here and find it right here. So let's imagine, like I said from the previous equation, our a equals 7 and our b equals 13. And so now we have 7 inverse 1, y minus 13 equals x. And so we had to find the 7 onto this table. They give you this table. This is called the Euclidean theorem. I'm not going to delve into it, but there are videos on YouTube if you guys want to learn how to do it. But they will give you the table during the exam. So instead of wasting time trying to find out the value through the Euclidean theorem, you can just immediately just look at it and find it. So this 7 inverse 1 is going to be equal to 15 right here. So you just had to find it somewhere on the table, and whatever number comes below on top of it. So 7 right here, you have 15. You have 7 over here, 15. So that means this value right here is going to be 15. And so you have 15 times, you distribute, multiply. If they give you a number right here, and then we'll go on to later how to solve specifically for decryption. But that's just what I want to tell you guys. And let's look at an example. So right here in this equation, we have a equals 7, b equals 13. So encode this string. Can't judge a book by its cover using the Affine cipher with a equals 7, b equals 13. So that means our equation will be y equals ax plus b mod 26. And so since we have our a values and b values, we can start immediately formulating a equation. So you have y equals 7x plus 13 mod 26. And if you want to do a decryption cipher like the one right here, if you guys go back, you'll see how the step-by-step procedures that I went through. You will get 7 inverse 1 y minus b equals x. And you have to find the mod 26 of this value right here. That's it, guys. I'll be meeting you guys in the next video, and we're going to be learning about affine encryption and decryption.